This is an experiment with a series connected SCR stack. So here's a closer look of the circuit. There's a high voltage input lead here, and that goes to a voltage divider, which is used to give me a signal for a LM311 comparator chip. And on that I have an adjustable threshold with a potentiometer. So when a threshold is reached, the signal goes to a 555 set up as a one-shot. That signal triggers an SCR, which discharges this capacitor through the primary of this transformer core here. And on that there are 5 individually isolated secondary windings. The output winding of our gate drive transformer goes to a diode and capacitor, which gives us a proper waveform to drive the gate on the series SCR stack. So the SCR stack is really set up as a voltage divider. There's our equalizing resistors, and there is a snubber network on each SCR. So when we trigger the gate, the snubber cap is discharged across each gate and gives us a good turn-on signal. There's an overall view, and for the load, I'm going to use a hollow core iron electromagnet. And the power supply for this, or I should say the capacitor, is 45 microfarads. And we have a charging resistor and a meter. This is an overall shot of the entire setup with the charging supply. The supply is good for 6,000 volts, but we're going to run this up to 2400, I hope. Okay, we'll crank up the voltage a little higher. Here's a shot of the magnet at 2000 volt discharge. Going to crank up the voltage. I don't want to take it over 2400. I'm afraid I'll flash the board over. Here's our magnetic waveform from a pickup coil 4 inches from our electromagnet. It's like 5 milliseconds on the positive pulse.